Section 8.5 deals with exponential growth functions, and we're going to kind of break this day down. We're going to do 1 day of exponential growth. Tomorrow's lesson will be exponential decay, and then Thursday we're going to look at kind of combining both and looking at more applications of these two types of functions. And so just in general, the goal is that after this video, or really by the end of tomorrow's lesson, you'll be able to successfully write and graph exponential growth models. Okay, we're not going to get into the models as much today as we are just the very basic idea of what an exponential growth function is. Okay, and so very basically, an exponential function is given this form: y equals a times b to the x. Okay, just like a line is y equals mx plus b, this is the format for an exponential function. Okay, you'll notice a can't be 0, because if a was 0, well then your equation would just be y equals 0. Y equals 0 is actually a line, and so that's why we have to have this restriction on the value of a. And you'll notice that your b has to be greater than 0, and it cannot be equal to 1. Again, otherwise, if b was equal to 1, you just have another line. It'd be y equals a, and that would just be, the graph of that would just be a line. Okay, and so that's what we're looking at here. So y equals ab to the x is the form that you need to be familiar with. Okay, so how do we find a function rule? Just, you already know how to write the equation of lines. Now we're going to write the equation of exponential functions. Okay, and the first thing you have to do is you have to find your b value. All right, and that b value is whatever each y value is being multiplied by to get the next y value. Okay, so you'll understand what I'm saying here in a minute when we go through and we actually look at this. But so again, the b value is the common multiplier. The a value is the value of y when x equals 0. Okay, from the table of given values or from a graph. And all you do then is, once you know your a and your b, you substitute it into this equation, y equals ab to the x, and you're done. Okay, so very basically, you'll notice now my table here goes up by, that's plus 1, plus 1. It's important to recognize that we're just going up by 1 here each time. Okay, and now you'll notice going from 1 to 4, and from 4 to 16, and from 16 to 64, and from 64 to 256, there's not anything, a linear equation, we'd be able to just add something. We'd be able to say, okay, this is plus 3, plus 3, plus 3. In this case, you'll notice the common theme is 1 times 4 is 4, 4 times 4 is 16, 16 times 4 is 64, 64 times 4 is 256. So the common multiplier is that 4 there. And so when they ask me to write a rule, again, I start with y equals a times b to the x. And I've identified it now. I know, again, my b is my common multiplier. So b here is 4. And then remember, it said that a is the value of y when x is 0. Well, when x is 0, y is 16. So my a value is 16. And so my final exponential function here is just going to be y equals 16 times 4 to the x power. All right? And that would be, that's my function there. Okay? So again, identify your a, identify your b, and then you can go ahead and write your equation. So again, it says I write a rule for the function below. So again, identify your common multiplier from here to here, from here to here. Now, you'll notice if you look at your first two values from 2 over 9 to 2 over 3, it's a little bit harder to see there. Okay, but if I look at the latter part of my deals here, it's easy to see that going from 2 to 6 times 3, from 6 to 18 times 3, from 2/3 to 2 times 3, and from 2/9 to 2/3 times 3. So identify that rule. So again, I got to find my a and my b. Well, I've already found my b. My b is the common multiplier. My a is my initial value, or the value when my x is 0. So my a is 2. And so then I go back and I say, well, I know that an exponential function looks like this: y equals ab to the x power. And now that I know what a and b are, I can go ahead and write my equation. So y equals 2 times 3 raised to the x power, and that would be my exponential function there, given that table there. Okay, and so again, that's the first idea, is being able to write an equation based on a table of values. The next thing I want you to be able to do after class tomorrow is graphing functions, graphing exponential functions. And really all we're going to do is we're going to create a table of values, and now you're going to see why we've talked about the properties of exponents, because when x is -2, I'm going to go ahead and do all my figuring down here. So when x is -2, that means I have y equals 2 to the -2, and we know that this negative exponent means I have to move it to the bottom, so it's really 1 over 2 squared, and we know what 2 squared is. 2 squared is just 4. So when x is -2, y is 1/4. When x is -1, that's y equals 2 to the -1. 2 to the -1 is just 1 over 2. I'm done there. When x is 0, I have y equals 2 to the 0. Remember, anything to the 0 power is just 1. So that's just 1. Let's see here. And then finally, when x is 1, we have y equals 2 to the first. And that's just 2. And so now I just plot these points. 0, 1 is that point there. 1, 2. And then I have what? -1 and 1/2. So -1, 1/2. And I have -2, 1/4, so I'm going to start getting closer and closer. And so you'll notice the exponential graph looks something like this, where we're getting bigger and bigger, and we're going to keep going up in that direction. Okay, so the domain of this exponential is all real numbers. Okay, remember, domain is x values. Okay, you'll notice there are going to be no restrictions on how far left and right my graph is going to go. Okay, it's going to go all the way to the left, it's going to go all the way to the right. So my domain is all real numbers. Now my range, a little bit different here. Range is the restriction on your y values. You notice that when it comes to going in the going up, okay, in the positive direction for y, that thing's never going to stop. That's why we have that arrow on there. Now you'll notice this exponential, it kind of curves down here, and so it's going to get awfully close to this y-axis, but it will never actually touch it. There's no value that I could plug in for x here that's going to make this y a 0. Okay, 2 raised to any power will always be bigger than 0. And so your range is all y values greater than 0. Okay, and so that's just kind of a general idea and general characteristic of an exponential function there. All right. We want to graph these 3 different functions and see how they are all related. Okay, so I'm going to go through this fairly quickly. I'm not going to do much figuring on the paper or on the screen here, but you should probably get in the habit of doing that on your own paper. So these negatives should be out in front. So that should be a -1, and that should be a -2. I apologize, I didn't realize that happened. So anyway, y equals 2 to the -2. That's 1 over 4. Let's see here, to the -1 is just going to be 1 over 2. This is the same function we just graphed. That's going to be 1, that's going to be 2, and that's going to be 4. Okay, and now now you'll see I'm just taking 1/2 times things. So 1/4 times a half, that's 1/8. 1/2 times a half is 1/4. 1 times 1/2 is 1/2. Half of 2 is 1. Half of 4 is 2. And finally, I have -1/2. So it's just going to be -1 over 8. It's going to be -1 over 4. -1/2, -1, and -2. Okay, and I'm going to graph all of these in a different color. I probably should have. Here's what I'll do. I'm going to go back over and retrace these. So I have 1 over 8, 1 over 4, 1 over 2, 1 and 2, and then we'll do the other one in black. So I have -1 over 8, -1 over 4, -1/2, -1, -2. This should make things a little bit easier. So I'm going to go ahead and graph that first function now. And again, that's the same one we had previously. So I have -2, 1/4. So -2, 1/4, -1, 1/2, 0, +1, 1, +2, and 2, +4. And so this graph is going to look something like, whoops, I apologize there. Something like that, close enough. Okay, and then if I graph the second function, when x is -2, y is 1/8. So -2, 1/8, I'm going to be a little bit smaller there. And when x is -1, we're at 1/4. So now I'm going to be about right there. Might be a little bit off, that's okay. Then at 0, I'm 1/2. So I'm actually going to move this guy down a little bit there. Okay, good enough. Let's see here. When x is 1, I'm at 1. and when x is 2, I'm at 2. And so this graph, you're going to notice, is a little bit lower here. It's going to go something like that. And finally, the very last function, when x is negative 2, y is negative 1/8. So negative 2, negative 1/8, negative 1, negative 1/4. And then I have, let's see here, 0 is negative half. And when x is 1, y is negative 1. When x is 2, y is negative 2. And so this graph now is going to go this direction and look something like that. Okay, and so again, just something to note here. This is how you would graph exponentials, and again, we'll look more at how these graphs are related here in a second. Okay, so here is the relationship. Okay, you identify the a value of a function when you want to determine whether something is a vertical stretch, a shrink, or a reflection of a parent graph. Parent graph just means there's nothing in front, so it's like y equals 2 to the x or y equals 4 to the x. Okay, you identify the a value of the function, and if the a is greater than 1, then it's a stretch. Okay, a vertical stretch. If the absolute value of a is smaller than 1, then it's a shrink. And if a is negative, then it's a reflection. Okay, and so you'll notice here some simple questions I could ask you, and we'll kind of keep that table there for you to kind of refer back to. Example 4 says, how does the graph of y equals 3, I'm going to move this guy over here so we can see this. How does the graph of y equals 3 times 5 to the x compare with the graph of y equals 5 to the x? Well, again, identify your a value. The a value here, since I don't see it as a 1, the a value here is 3. Okay, well again, the a value is greater than 1, so this guy here has to be a stretch. Okay, and it's not negative, and the absolute value of a is not smaller than 1. So this is just very simply a vertical stretch. All right, so when the number out in front is bigger than 1, it's a vertical stretch. If I go back here and I look at my graph here, you'll notice, well, actually I don't have any stretches here. They're both shrinks. Okay, but if it were a stretch, the graph would look something like this. It would be on this rate, but it would increase quicker. Okay, and so that's kind of what we mean when we say a vertical stretch. You take it and it would go vertical more quickly. Okay, when you shrink it, okay, you actually make it wider. Okay, let's see here. Go on to the next one. So it says, how does the graph of y equals negative 4 to the x power compare with the graph of y equals 4 to the x? Okay, again, identify the a value, identify the guy out in front. Since I don't see it, since this is negative, okay, that means there's a negative 1 times 4x out in front. So again, here we are, okay, it's negative. The absolute value is not smaller than 1. So very simply, all we're going to say here is that this thing is a reflection, okay, because the a value out in front is negative. The last example we're going to look at here says, how does the graph of y equals negative 2 times 8 to the x compare with the graph of y equals 8 to the x? And so I look at it and I say, well, first of all, I do know that the a value, okay, the a value, the negative 2, whoops, sorry about that. So this negative 2 here, it is negative, so immediately I know it's a reflection. Okay, so this negative tells me it's a reflection, and then I look at the value of 2. Since 2 is bigger than 1, okay, 2 is bigger than 1, that means I'm going to have a vertical stretch. So I not only have a reflection, but I also have a vertical stretch as well. Okay, so that one kind of combines a couple ideas that we've looked at involving the shrinking, stretching, or reflecting of a graph. Okay, so again, I know that there's probably a lot of new stuff in this section. So if you have any concerns or any questions, make sure you bring them to class tomorrow, and we'll make sure that we take care of them.